Hello everyone and welcome to Aviation Physics. I am Dr. Chen. Today we will covering a fundamental topic in physics, thermodynamics. Please reach out if you have any questions. Alright, let's get started with thermodynamics. We'll begin with the concept of thermal equilibrium and temperature. So what is thermal equilibrium? It's the state where two objects in contact reach the same temperature, and as a result, there is no more net transfer of thermal energy between them. Look at the diagram. Initially, you have a hot object at 100 Celsius degree, next to a cold one, 0 Celsius degree. Thermal energy or heat naturally flows from the hot one to the cold one. After some time, they both reach a steady intermediate temperature. In this case, 50 Celsius degree. At this point, they are in thermal equilibrium and the energy transfer stops. This leads us to the zeroth law of thermodynamics. It might seem strange to have a zeroth law, but it was formulated after the first and the second laws and was considered so fundamental that it needed to be preceded them. That's why it's called zeroth law. The law states if object A and B are separately in thermal equilibrium with the third object C, then A and B are in thermal equilibrium with each other. This is a principle that makes thermometers work. In the illustration, object C is a thermometer. If it measures the same temperature for object A and object B, then we know that if we put A and B in contact, no heat will flow between them. The zeroth law of thermodynamics, let's restate it again. If object A and B are separately in thermal equilibrium with the third object C, then A and B are in thermal equilibrium with each other. This statement is important because it makes it possible to define temperature. We can think of temperature as a property that determines whether an object is in thermal equilibrium with other objects. Two objects in the thermal equilibrium with each other are at the same temperature. Now let's talk about thermometers and temperature scales. Common thermometers are calibrated using key physical points like the freezing point, which is 0 Celsius degree, and the boiling water, which is 100 Celsius degree. A very precise type is the constant volume gas thermometer. Its operation is based on the fact that the pressure of a gas at constant volume increases linearly with temperature. If we extrapolate the pressure-temperature graph for gas, the pressure reaches 0 at a temperature of negative 273.15 Celsius degree. This is the basis for Kelvin scale, where this point is defined as absolute zero, or 0 Kelvin. The Kelvin scale is what we used for most scientific work. This chart shows the vast range of temperature in the universe, from near absolute zero, lowest temperature achieved on Earth, which is 10 to the negative 10 Kelvin. The corona of the sun is about 1 million Kelvin, and the interior of the sun is 10 million Kelvin. The hydrogen bomb can create a temperature which is 100 million Kelvin. The highest temperature that we observed in the universe is about 1 billion. Here you can see the three main scales, Celsius, Fahrenheit, and Kelvin, side by side, with the freezing and the boiling point of water as a reference point. This is ice point. This is boiling water. And these are the formulas how to convert between those three different temperature scales.